The night was windless. Over the vast silence of the South African Karoo Desert, the air seemed to breathe in slow, invisible rhythms. This place, one of the quietest on Earth, has always felt like the boundary between two worlds, the stillness of stone and the endlessness of the stars. No hum of cities, no glow of human light. Only the dark vault of the sky, shimmering with a billion distant fires, and the steady metallic hum of the great antennas of the Meerkat radio telescope. The vigilant eyes of humanity turned toward infinity. It was here, beneath that colossal dome of stars, that something extraordinary happened. What began as an ordinary night of observation became the start of a mystery that would soon ripple through every observatory on the planet. The operator on duty noticed a faint, irregular noise on one of the monitoring screens. Not a burst of energy, not a signal in the classical sense, but a peculiar whisper in the spectrum. It wasn't rhythmic, yet it carried a strange coherence, as though hiding an intent. The team enlarged the data scale, amplifying the faint tremors of the unknown. Slowly, peaks emerged, repeating, deliberate, forming a rhythm that seemed to breathe. The scientists exchanged glances. Instruments were recalibrated, atmospheric interferences excluded. But the pattern remained. It was not terrestrial, not a reflection from any known satellite or deep space probe. It came from the vast emptiness beyond the orbit of Mars. As they traced the signal, its source became clear: a small celestial visitor, an interstellar comet catalogued as 3I, known as Atlas. The name alone carried weight, a myth reborn in the language of astronomy. The second known object ever to arrive in our solar system from beyond its borders. The first, Oumuamua, had already shaken scientific thought with its strange shape and non-gravitational acceleration. But 3I Atlas was different. Its behavior defied logic. When the first analysis of the radio spectrum came through, confusion filled the control room. This was not thermal noise, not the usual hiss of evaporating ice and dust. It was modulated, pulsing in distinct intervals, almost as if someone, or something, was pressing a hidden switch on and off again and again. One of the engineers staring at the data stream noticed something that froze him mid-sentence. Within those intervals was an unmistakable mathematical order. The sequence 1, 2, 3, 5, 8, 13, the Fibonacci progression. Coincidence, perhaps, yet too perfect to dismiss. The Fibonacci pattern is not just a mathematical curiosity. It is the rhythm of nature itself. The spiral of galaxies, the geometry of seashells, the veins of leaves, even the structure of human DNA. And now it pulsed in the heart of a comet from beyond the stars. When they filtered the background noise and isolated the pure signal, a hush fell over the lab. For a long time, no one spoke. The hum of the computer seemed suddenly deafening. Could this be a reflection of solar wind? One astrophysicist asked softly. Or, another replied, almost whispering, could it be something more? No one dared to answer. Days passed, then weeks. The comet slipped behind the sun, vanishing from sight and from data. The world moved on, but those who had seen the strange pattern could not forget. The faint pulse haunted their thoughts, a breath from the dark. Months later, when Atlas reappeared, it was no longer the same. Its tail had grown longer, denser, and unnervingly symmetrical. Spectroscopic readings showed irregularities. Its core seemed fractured, yet it pulsed with light, as though alive. Speculation ignited across observatories. Had it collided with an unseen object? Had the sun's heat transformed its structure? Or was it responding to something? Then came the observation from Mount Lemmon Observatory in Arizona. The operator recorded a single line in the nightly log. Object behaves more like a ship than a comet. That phrase spread like wildfire through the scientific community. Debate erupted. Some insisted it was a simple matter of outgassing and altered mass. Others, more cautious, admitted the data was unexplainable. When telescopes in Chile and Japan turned their gaze toward Atlas, they reported a phenomenon unseen before. The comet's brightness pulsed in sync with a repeating radio frequency. Each flare of light corresponded precisely with each radio surge, as though the object itself were transmitting in rhythm with its own glow. Coincidence again, perhaps, but how many coincidences can the universe hold before they become patterns of intent? By now, amateur astronomers joined the watch, uploading recordings, dissecting the radio patterns, comparing waveforms. Forums erupted with theories. Some believed it was a lost probe, ancient and self-aware. Others whispered of an encoded message, hidden in the mathematics of its pulse. When the data was converted to audible sound, the pattern resembled breathing, a steady, calm inhalation and exhalation in the darkness of space. No words, no melody, only rhythm. Yet those who heard it spoke of an uncanny emotion that could not be defined, something vast, ancient, and patient. And so, from the still desert of Karoo to the frozen peaks of Chile, the world began to listen. To a whisper, not from within, but from far beyond. Something was speaking. Or maybe something was simply alive. The question was no longer what 3i Atlas was, but who, or what kind of intelligence could leave behind such a trace in the cosmic silence. And somewhere in the deep hum of the universe, beneath layers of noise and time, the pulse continued, slow, deliberate, as though waiting for an answer. For months, the world's observatories had been silent about the strange signal from the interstellar comet known as 3i Atlas. Official reports described it as natural background interference, a side effect of solar wind interacting with dust and ionized gas. But behind the curtain of scientific restraint, curiosity burned. Something in that faint radio pulse defied every known model of cometary behavior. What was first dismissed as random fluctuation began to reveal a deeper pattern, one that could not be reduced to chance. And when the object re-emerged from behind the sun, the pattern returned, stronger, clearer, as though the darkness itself had learned to speak. At the South African Radio Astronomy Observatory, the team working with the Meerkat array began cross-correlating old data. They compared the new radio bursts with those recorded during the comet's first passage. The alignment was uncanny. Each interval, each rise and fall, matched perfectly, as if the emitter had paused during its disappearance and then resumed the sequence without missing a single beat. The probability of such synchronization by pure coincidence was infinitesimal. The team began to treat the data not as noise but as a coded sequence. Spectral analysis revealed modulation that appeared to repeat in cycles of 8 pulses, a number suspiciously close to the rhythmic frequency of a human heartbeat when converted into the audible range. When this discovery reached the European Southern Observatory in Chile, a special cross-disciplinary task group was formed, joining radio astronomers, mathematicians, and data analysts. Their task: determine whether the emission from 3i Atlas was of natural origin. They called it Project Echo. Using long baseline interferometry, they triangulated the precise coordinates of the source. There was no error. The emission originated directly from the comet's nucleus, a compact body only a few kilometers across. Its tail extended in a double arc, glittering in reflected sunlight, but the radio source was localized, not diffused. That alone defied known models. Ordinary comets emit broad-spectrum noise caused by ionization processes. Atlas emitted narrow-band pulses, concentrated in the centimeter range. The signal had a carrier frequency of roughly 2.3 gigahertz, a band typically used by spacecraft communication on Earth. The coincidence unsettled everyone. As new observations poured in from observatories in Japan, Chile, and Spain, a strange regularity emerged. The intensity of the radio bursts correlated with changes in the comet's brightness. When the light of the nucleus flared, the radio pulse intensified. When it dimmed, the signal weakened. Every fluctuation mirrored its counterpart with uncanny precision. The phenomenon was recorded independently across 3 continents, eliminating any suspicion of instrumental error. The more data the teams collected, the more the object seemed to defy physics. In February of that year, NASA's Deep Space Network antennas joined the monitoring effort. They pointed toward the coordinates of 3I Atlas, capturing a high-resolution spectrum of its emissions. The resulting graphs revealed an almost musical structure, a harmonic distribution where energy peaks formed ratios close to the Fibonacci sequence. In the language of mathematics, such ratios describe growth patterns in living organisms and natural systems that evolved toward equilibrium. But how could a block of ice and dust drifting through the void produce such symmetry? Dr. Eleanor Vance, a senior researcher at the Jet Propulsion Laboratory, wrote in her preliminary report that the sequence displayed a level of internal order that is statistically improbable for purely thermal emission. Yet she stopped short of calling it artificial. Nature, she wrote, has a way of creating structures that mirror intelligence, even when none exists. The universe may simply be repeating its own rhythm. Her words calmed few. Across the Atlantic, at Cambridge University's Institute of Astronomy, a group of theoreticians led by Dr. Arjun Patel approached the problem from another angle. They ran simulations of how a rotating, fracturing nucleus might modulate reflected sunlight and electromagnetic radiation. To their astonishment, no known physical model produced the same repeating pattern. Every attempt resulted either in random noise or in chaotic oscillations. None displayed the delicate self-similar order recorded by the telescopes. As these debates unfolded, the public caught wind of the mystery. Amateur radio astronomers began intercepting the comet signal using homemade dishes and modified receivers. Some reported hearing what they described as a soft mechanical breath when the data was converted to sound. Social media buzzed with theories of alien probes and sentient comets. Official agencies tried to contain the speculation, releasing carefully worded statements about natural periodic variations. But each new measurement brought another layer of contradiction. Then came the event that changed everything. On the 23rd of April, while 3I Atlas crossed the plane of Earth's orbit, the Meerkat Array recorded a sudden surge of emission, a flare nearly 50 times stronger than anything previously detected. For 7 minutes, the comet shone brighter than any object of its kind ever recorded. The radio spectrum widened, and within it, analysts discovered an extraordinary feature, a narrow band of amplitude modulation that repeated every 55 seconds. The pattern corresponded exactly to the numerical ratios 1, 2, 3, 5, 8, 13, 21, truncated only by the limits of the observation window. It was the Fibonacci sequence, complete and precise, encoded in energy itself. At first, the scientists refused to believe it. The data was reprocessed, filtered, and examined by independent teams in Germany and Canada. Each reached the same conclusion. The modulation was real. It could not be explained by solar wind interference, plasma resonance, or cosmic background fluctuations. Something within or around the comet was organizing electromagnetic energy into a mathematical pattern. A quiet unease spread through the scientific world. NASA's spokesperson called for patience, emphasizing that extraordinary claims require extraordinary evidence. But within private correspondence between observatories, another tone prevailed. The internal memo from the European Space Agency read, "We are observing a phenomenon that challenges our current understanding of non-gravitational forces acting on interstellar bodies." When the Hubble Space Telescope captured a new image of 3I Atlas, the photographs showed a structure unlike any ordinary cometary coma. The tail appeared braided, strands of luminous material twisting around each other like threads of DNA. The resemblance was unsettling. Some researchers suggested it was a complex interaction between magnetic fields and ionized dust, but the symmetry was far too perfect. The braids maintained equal spacing over distances of thousands of kilometers, curving in a precise golden ratio. At the same time, spectroscopy detected compounds never before observed in cometary material. Among them were traces of long-chain carbon molecules similar to those that form the basis of organic chemistry. That discovery alone was historic, the first direct evidence that interstellar objects could carry prebiotic materials between stars. Yet in the context of the rhythmic signal, it deepened the enigma. Was Atlas merely a carrier of life's ingredients, or was it exhibiting the patterns of life itself? Theories multiplied. Some hypothesized that the comet's nucleus contained a quasi-crystalline lattice capable of resonating with electromagnetic energy, producing self-amplifying feedback loops. Others speculated that it might harbor trapped plasma fields, behaving as a natural oscillator. But none of these models explained the perfect correspondence between light and radio waves. The two phenomena, optical brightness and electromagnetic emission, were synchronized with mathematical precision, as if governed by an internal clock. Then, a bold experiment was proposed. The South African team decided to transmit a narrow-band test signal toward 3I Atlas. The frequency chosen matched the observed carrier wave, offset slightly to avoid interference. It was not an attempt at communication officially, but rather a calibration test, a way to measure how the object's emission might reflect or scatter external input. The transmission lasted only 30 seconds. For several minutes, nothing happened. Then, the detectors registered a faint but distinct reply, a modulation echo that matched the transmitted pattern, delayed by the exact time required for a two-way journey at light speed. Coincidence, perhaps again. A reflection from ionized dust. Yet the timing was flawless. The team repeated the test the following night with a different frequency. The response came once more, this time with a slight variation, as though the returning signal carried a subtle distortion, not random, but structured. Spectral analysis showed sidebands forming a geometric progression identical to the sequence already observed. When converted into audible sound, the echo resembled a whisper, soft, indistinct, almost human. The results were classified immediately. Officially, the experiment never happened, but fragments of the data leaked through anonymous channels and appeared on independent research forums. The community erupted. Some called it the greatest discovery in human history. Others dismissed it as data manipulation or misinterpretation. Yet the pattern of the echoes, undeniable in their elegance, ignited imaginations. Meanwhile, the comet continued its journey. As it approached perihelion, the closest point to the Sun, its luminosity intensified dramatically. The nucleus began to fracture, releasing plumes of gas that twisted into spiral shapes. The light curve oscillated with rhythmic precision, the same 8-beat cycle observed months earlier. Even as it broke apart, 3I Atlas seemed to pulse with life. Astronomers at the Atacama Large Millimeter Array detected sub-millimeter emissions consistent with rapid outgassing, but also noted microbursts of coherent radiation, the kind produced by maser activity, similar to natural lasers in space. These bursts followed the same modulation pattern as before. Nature, it seemed, was unwilling to let go of its secret. In a closed session at the International Astronomical Union, representatives from several agencies debated the classification of the object. Was it a comet, a fragment, or a new category altogether? Dr. Yuko Tanaka from Japan's National Observatory proposed the term organismic body, suggesting that the comet's structure exhibited feedback mechanisms reminiscent of living systems. Her paper was politely rejected for lack of empirical evidence, yet her phrase spread rapidly through informal circles. The idea that 3I Atlas was alive captured the imagination of both scientists and the public. At the height of speculation, a new dataset arrived from the James Webb Space Telescope. It revealed that the chemical composition of the dust surrounding Atlas included amino acid precursors and complex hydrocarbons, the very molecules that underlie life's architecture. The finding linked 3I Atlas to theories of panspermia, suggesting that comets could serve as vessels carrying the seeds of biology between star systems. In that sense, the interstellar visitor was not just an anomaly, but perhaps a messenger from the cosmic ocean that gave birth to life itself. As the comet began to recede from the sun, its brightness slowly diminished. But the radio emissions persisted, faint yet stubbornly regular. Even as it moved beyond the orbit of Jupiter, the sequence continued, the same Fibonacci rhythm pulsing across the cold emptiness. Observatories tracked it until the signal faded into the galactic background. When the final dataset was compiled, it contained 1,000,000 lines of numbers, intervals, amplitudes, frequencies. Hidden within them, researchers noticed one last anomaly. The final pulses of the comet's signal formed a pattern that, when mapped into polar coordinates, traced a perfect logarithmic spiral, the mathematical expression of growth, balance, and harmony. The same curve found in galaxies, hurricanes, and living shells. It was as if the universe had signed its work with a flourish, reminding humankind of a truth both ancient and profound. Order is not confined to life. Life itself may be the order that the cosmos breeds. Whether 3I Atlas was a coincidence of nature or a deliberate design remains unknown. Yet for those who listened to its pulse in the silence of night, the experience changed something fundamental. They had glimpsed, if only for a moment, the possibility that the universe is not a cold void, but a vast mind unfolding through rhythm and form, and that perhaps, somewhere beyond the stars, it had just whispered back. Long after 3I Atlas disappeared beyond the reach of our most powerful telescopes, its story continued to echo through the corridors of science. Every laboratory, every observatory, every classroom that looked toward the night sky felt its presence like an unspoken question. What had we truly witnessed in those fleeting months when a visitor from another star brushed against the edge of our world? Was it merely a natural body, a frozen relic of forgotten systems, or had it been something more? Something that reflected the intelligence of the universe itself. To understand the weight of that question, one must return to the heart of the discovery, to the people whose lives intertwined with the comet's silent journey. Among them was Dr. Eleanor Vance, who had led the spectral analysis team at the Jet Propulsion Laboratory. For years, she had studied the faint whispers of radio pulsars and magnetars, mapping chaos into coherence. But Atlas changed her. She often said that it was the first time she felt science breathe. In interviews, she spoke softly, her eyes distant, describing how the signal had seemed to pulse with intention. It was not language as we know it, she explained, but something that felt alive, a rhythm beyond meaning, yet filled with it. After the data vanished from public archives, she left her position and joined a private research foundation in Chile, dedicating herself to the study of natural resonance patterns in cosmic dust. Those who worked with her said she became convinced that life might not need cells or DNA, only structure and rhythm. Others followed different paths. In Cambridge, Dr. Arjun Patel continued to simulate the behavior of interstellar bodies, refining his models until they blurred the line between astrophysics and philosophy. He proposed that 3I Atlas could have been a fragment of an ancient planetary system, one that developed self-organizing chemical matrices capable of responding to electromagnetic fields. In his later writings, he described such entities as proto-minds of the cosmos, not conscious in the human sense, but evolving toward awareness through patterns of energy. His paper was largely dismissed, yet his theory found quiet admiration among young scientists who grew up during the era of the comet. To them, the mystery of Atlas represented not fear of the unknown, but the thrill of meeting it face to face. Meanwhile, in South Africa, the operators of the Meerkat array, those who had first recorded the strange whisper, preserved every backup copy of their data stored deep within the observatory's archives. They would sometimes gather beneath the antennas after midnight, when the desert wind turned cold, and play the sound of the signal through speakers. The low hum filled the air like a heartbeat, a pulse of the cosmos itself. To them, it became almost sacred, a reminder that silence can be as full of life as any sound. In the years that followed, researchers attempted to reconstruct the physical evolution of 3I Atlas. Using composite imagery and dynamic simulations, they traced its trajectory from its entry into the solar system to its final departure. They discovered subtle anomalies, minute changes in velocity, unexpected deviations that suggested an external force had influenced its motion. No gravitational field could account for it. The simplest explanation was internal outgassing from sublimating ice, yet the timing of those thrusts coincided eerily with the radio bursts. Each time the comet spoke, its course shifted slightly, as though the signal and its movement were intertwined. This finding reignited the debate about self-regulation in non-living systems. Could a structure, purely physical, exhibit feedback loops so precise that it appeared to make decisions? In the laboratory models that followed, scientists found that certain crystalline structures, when exposed to varying magnetic flux, could indeed oscillate and self-correct their energy states, a process that mirrored primitive metabolism. If the nucleus of 3I Atlas contained similar formations, then perhaps what humanity had witnessed was not intelligence, but the shadow of it, an echo of the process by which matter organizes itself into meaning. Yet beyond the walls of laboratories, the story took on another form. Artists painted Atlas as a living being of light and dust, drifting through the abyss in search of its origin. Poets wrote verses about a voice in the dark that had waited for billions of years to be heard. Musicians transformed the radio pulses into symphonies that blended electronic resonance with orchestral sound. To many, Atlas became a symbol of the dialogue between humanity and the universe, a reminder that discovery is as emotional as it is rational. But perhaps the most profound reaction came from the field of philosophy. A group of thinkers known as the resonantists emerged, arguing that consciousness is not confined to organic matter, but is instead a universal phenomenon, present wherever rhythm, order, and feedback exist. They cited the Fibonacci pattern in the comet's signal as evidence that life and intelligence are not separate from physics but born of it. Their view spread quietly, influencing how new generations of scientists perceive the cosmos, no longer as an indifferent void, but as a vast organism in which every particle participates in an ongoing symphony of connection. When the data from the James Webb Space Telescope was finally declassified decades later, new details surfaced. The spectroscopy confirmed that 3I Atlas carried compounds unknown to our solar system, chains of carbon atoms intertwined with elements rarely found in combination elsewhere. These molecules were fragile, easily destroyed by solar radiation, yet somehow the comet's nucleus had protected them, as if preserving a message from its home system. By then, the object was long gone, vanishing into the outer dark, but the remnants of its dust trail had reached the orbit of Mars. Some of it entered Earth's atmosphere as microscopic meteors, burning in silence high above the night sky. Whether any fragment survived to fall upon the ground remains uncertain, but for those who watched the meteor showers that year, each streak of light felt like a reply, fleeting, beautiful, and deeply personal. There were other echoes, too. In radio archives around the world, faint bursts resembling the Atlas signature continued to appear intermittently. Most were dismissed as interference or reflections from distant pulsars, but a few carried the same distinct modulation, the gentle, deliberate rhythm of 8 beats. Some claimed these were remnants of the comet's final emissions, refracted through interstellar plasma. Others wondered whether the pattern had always been there, scattered through the background of the universe, unnoticed until we learned how to listen. With time, the scientific community reached no consensus. The official narrative settled into caution. 3 Atlas, they said, was an interstellar object of unknown composition exhibiting unusual but natural electromagnetic phenomena. Yet among those who had witnessed its mystery firsthand, few were satisfied. For them, the comet had revealed not an answer but a mirror, reflecting our own desire to find meaning in the chaos of creation. Perhaps that was its true message.